Ascent Audio, a division of Recorded Books presents Teaching with AI, a practical guide to a new era of human learning, by José Antonio Bowen and C. Edward Watson. Narrated by Andrew B. Wehrlen. Publisher's Note: in this audio edition, you will hear references to figures present in the print and e-book formats of the book. Chronology. 1950s. Artificial intelligence research gets going, but is focused on expert or logical systems. 1959. Arthur Samuel coins the term machine learning. 1967. Joseph Weizenbaum creates Eliza, the first significant chatbot and LLM that marked the beginning of work into natural language processing, NLP. 1980s. Google's search algorithm, which learns from your search history, helps stir a revival in machine learning as an AI strategy. 1990s. Deep learning and artificial neural network research begins to grow. 1997. IBM's Deep Blue beats Garry Kasparov in chess. 2010. DeepMind, founded by Demis Hassabis, Shane Legg, and Mustafa Suleyman. 2014. Ian Goodfellow proposes generative adversarial networks, which lead to many new types of neural networks that are both generative and able to be trained. 2016. AlphaGo, a machine learning AI from DeepMind, beats world champion Lee Sedol at Go. 2017. Transformers make it possible to both decode and generate new text. 2018. First GPT LLM created by OpenAI. 2021. DAL-E, built on GPT-3, is a machine learning model that generates images. 2022. GPT 3.5 launched in November. AI apps begin to proliferate. 2023. GPT-4 released in March, followed by Bard by Google, Claude by Anthropic, Llama by Meta, and Grok by X. Introduction. Nothing in life is to be feared. It is only to be understood. Now is the time to understand more, so that we may fear less. Marie Curie, Nobel laureate in physics, 1903, and chemistry, 1911. There is a great deal to understand about AI. Like the internet, AI is a technology that is going to change everything, and not just education. The internet, and more specifically the World Wide Web, fundamentally changed our relationship with knowledge, moving us from a world where knowledge was scarce, but mostly reliable, to one where knowledge was abundant, but largely unreliable. When this framing was first floated, we were all using the internet on our desktops. The iPhone was yet to arrive. We could all appreciate the increased access to research materials and expertise, but we were already wary of the rise of unfiltered and sometimes sinister misinformation. And with the struggles of dial-up, it was easy to underestimate the coming ubiquity of the new technology. Speed, ease of access, and platforms changed the mechanics and magnified the effect, but not the trajectory. Our relationship with knowledge was changed forever, and in turn everything from education and shopping to culture and politics was altered. If the internet changed our relationship with knowledge, AI is going to change our relationship with thinking. It is already challenging ideas about creativity and originality, and it will forever alter education, work, and even how we think about thinking, both human and AI thinking. Perhaps we can learn some lessons from the rise of the internet. Just as later technologies, like the iPhone and social media, amplified the effects of the internet, we can assume that AI is going to get better and more intertwined with our lives in the future. Banning web-based tools like Wikipedia failed, but would the internet have turned out differently if we had put different constraints on how it developed? AI has already challenged and divided us faster than the internet did. Some of what we present will have evolved by the time this gets to publication, Still, in 2006, we didn't need to know the specific convergence devices or social media platforms that were to come to know that information would soon be less reliable. Rapid change is again unfolding, and we can use what AI can already do to plan for a future in which our relationship with thinking will be fundamentally altered. Ethics and Equity. We have tried to keep this book short and focused on the practical. In almost every section, we could have, and maybe should have, dived into ethical problems and ambiguities. We are sure someone will write that book. As we learned from the internet and social media, there are a million ways the expansion of AI could go wrong and increase inequities, take jobs, and damage human lives. But if you watch Netflix, use a spam filter, shop at Amazon, or drive a car, you are already a part of the new AI economy. The creation of consumer-grade, much more human-sounding chatbots has brought attention to AI and is a real breakthrough that will change our lives. The implications of being able to process virtually anything, data, music, images, computer code, DNA, or brainwaves, as language, and at scale, however, is mind-blowing and needs careful consideration. It is essential that educators start to talk about these issues with students. If we want students to use AI responsibly, both in school and beyond, AI ethics must be baked into curriculum and include AI literacy, an emerging essential skill. AI is already increasing inequity both in education and beyond, but it also has the potential to be a tool for equity. AI can provide more feedback to improve learning, increase human creativity, and customize materials for groups or individual students. Teachers will be in an important position to determine whether AI transforms education for better or worse. We tried to provide multiple examples of this with the goal of offering the most practical and urgent information. You won't like every suggestion or application of AI, but we avoided too much commentary to keep the book from becoming a brick. We have left space for you to make up your own mind. Students. We quote as much data on how students are using AI as we could find, but given the speed at which things are changing, we also did our own research. We talked to a lot of students, mostly in small groups. We interviewed students from many different types of institutions, public and private, elite and regional, two-year colleges to R1 doctoral universities. We also asked students to read key sections and chapters, especially on cheating. It was not a large statistical sample, but we used this feedback and these personal stories to add a context to the larger research findings. Your students may be different, but we urge you to consider that students do not like admitting to cheating, or what might be viewed as questionable or embarrassing practices to their own faculty, or to their parents, or to researchers. In the same way that voters often say one thing in a survey and then do another in the ballot box, the students we interviewed consistently reported that everyone, 100% of students, were using AI. This is not a finding replicated in surveys, but the questions in those surveys vary. Students were quick to point out that there were lots of different types of usage, and that they did not consider a lot of it to be cheating. Outline and organization. This book is organized into 3 parts: Thinking with AI, Teaching with AI, and Learning with AI. The first part is about how AI works and what it is doing to the human experience. Chapter 1 starts with terms and enough history to illuminate why this all seems so sudden. If you really don't care what GPT stands for and why it matters, you can skip this bit. The really important implications appear in chapters 2, 3, and 4. And yes, the CS experts we asked to read chapter 1 questioned some of our colorful analogies in the drafts. So, apologies for this more technical chapter. Do not skip chapter 2, which chronicles how the world of work and job interviews has already changed for our graduates. AI will eliminate some jobs, but it seems very likely to change every job. This could be good or bad, but we are all likely to be asked to do more and better work more quickly. AI literacy requires knowing enough about how AI works to be able to use it effectively. Breaking down problems and asking better questions have long been a cornerstone of higher education, and these are critical skills in using AI too. Chapter 3 categorizes this process, from articulating the problem, finding the right AI for the task, creating better prompts, and then iterating with AI. Chapter 4 focuses especially on the uniquely creative nature of AI as a prediction machine without the inhibitions of social embarrassment. An AI will say anything. The problem of hallucinating becomes a strength when the task is coming up with new ideas. In both chapters, it becomes clear that the benefits that come from AI come from using it as a partner to human thinking. Part 2 shifts the focus to teaching.
Chapter 5 looks at what AI can already do for faculty and what it might soon do.
Chapter 6 analyzes the much-discussed problem of cheating, with research-backed findings about AI detection, which is functionally more challenging than plagiarism detection. Understanding cheating is essential, not because detectors will eliminate it, but so we can redesign assignments that will make cheating less rewarding and useful, while also improving learning. If students are collaborating with AI to produce better work, they may be onto something. What we call cheating, businesses see as innovation. From this follows a discussion of potential policies, Chapter 7, and grading, Chapter 8. Since all assignments are now AI assignments, you need a policy that defines how work should be done and why. Grading especially needs to be rethought. No one is going to hire a student who can only do C work if an AI can do it more cheaply. We will need to define what better than AI work looks like. The last part of the book is devoted to designing assessments and assignments in this new era. Chapter 9 looks at how AI can customize learning and create individual feedback for students. Chapter 10 outlines new design principles and how we can better guide a process and make it visible. The last 2 chapters apply these principles in copious examples, with Chapter 11 focusing on writing and Chapter 12 experimenting with new ideas. Prompts and responses. We obviously spent a lot of time testing ideas with different AIs.
We've included many of our specific prompts identified by the header, prompt. We wanted it to be very clear when we were quoting exactly from an AI, so we identified the responses under the header, response. We've also listed the AI we used, the version, and the date. APA currently only suggests the date, but the version, GPT 3.5, 4, or Turbo, for example, also matters. AIs tend to be verbose, so most of the responses are abridged, which is also indicated. We reran prompts as close to the publication date as possible, often with newer versions of a particular AI. Sometimes we left an earlier response, or used the free GPT 3.5 response as an example of what a cheap and basic response might be.
Sometimes good is good enough, and we know that many students and faculty will be limited to free versions. Since prompts will return a different and unique answer each time, we have included responses only where they were important to the point at hand.
Including complete responses from multiple AIs would have made this book much longer for limited gain.
You will want to customize and experiment with the prompts yourself. Part 1. Thinking with AI. Chapter 1. AI Basics. AI is one of the most important things humanity is working on. It is more profound than electricity or fire. Sundar Pichai, CEO of Google and Alphabet. If you were busy on November 30, 2022, you might have missed the early demo that OpenAI released of its new chatbot. But after 5 days, more than 1 million people had tried it. It reached 100 million daily active users in 2 months. It took TikTok 9 months and Instagram 2.5 years to reach that milestone.
But bigger than fire? Sundar Pichai has made this comparison repeatedly, but few of us were listening when he said it publicly in January 2016, when he also admitted he did not really know how AI worked. Fire, like other human technological achievements, has been a double-edged sword, a source of destruction and change as well as an accelerant to advancements. AI is already on a similar trajectory. Most of us have heard of AI.
Some may even remember when a computer beat the chess world champion, but that was a different sort of AI. As happens in many fields, think mRNA vaccines, research over decades takes a turn or finds a new application, and a technology that has been evolving over years suddenly bursts into public awareness. For centuries, humans looked for easy ways to rekindle fire in the middle of the night. Early chemical versions from Robert Boyle in the 1680s to Jean Chancel, 1805, were expensive, dangerous, or both, and never made it to mass production. Then, chemist John Walker accidentally discovered, in 1826, that friction could make the process safe and cheap. Like matches, 70 years of scholarly work in AI helped create the recent explosion of awareness. But in a GPT flicker, the world has changed. Expert systems versus machine learning. The term artificial intelligence, AI, was coined in 1956 at a conference sponsored by the Defense Advanced Research Projects Agency, DARPA, to imagine, study, and create machines capable of performing tasks that typically require human cognition and intelligence. We've summarized the definitions of key terms in glossaries that can be found at the end of some sections. Early AI research focused on logic, or expert systems, that used rules designed to anticipate a wide range of possible scenarios. These systems don't improve with more iterations. This is how robots and AI are still often portrayed in stories. Even in Star Trek, the emergency medical hologram is constantly limited by its programming. IBM pioneer Arthur Samuel, 1959, coined the term machine learning to describe statistical algorithms that could generalize and learn to play a better game of checkers than can be played by the person who wrote the program. For a simple game like checkers, it was possible to develop an expert system that could search a database but also make inferences beyond existing solutions. Samuel's checkers program, however, was given only the rules of the game, a sense of direction, and a redundant and incomplete list of parameters which are thought to have something to do with the game, but whose correct signs and relative weights are unknown and unspecified. Expert systems and their logical reasoning initially dominated research, but machine learning, with its probabilistic reasoning, was more useful in recognizing patterns. It became a more central part of AI research in the 1990s. With more memory and larger data sets, statistical algorithms were able to deduce medical diagnoses. WebMD, for example, and eventually led to IBM's Deep Blue chess program beating chess champion Garry Kasparov in 1997. Machine learning plus neural networks equal foundational models. Neural networks are computing systems modeled like the neural connections in the human brain. Neural networks are a specific type of machine learning model where nodes, individual computational units, are organized into layers that mirror our understanding of the human brain. In the 1960s and 70s, networks were logical and linear if-then structures, like following directions from your GPS. But they have become more decentralized layers of interconnected nodes, like knowing lots of different ways to get between 2 points. Neural networks need to be trained, usually on large data sets. This training can either be supervised, where the data is labeled so that the model learns the association between inputs and desired outputs, or unsupervised, where the input data is unlabeled. Once a supervised model is trained, it can classify new inputs. This is how your spam filter works. Unsupervised machine learning generally requires larger data sets, but can then associate or cluster unseen trends and relationships. The more you watch Netflix, the more it discovers connections among the things you actually like, and realizes that the documentary you saved about goldfish was a mistake. A third machine learning paradigm, alongside supervised and unsupervised, is reinforcement learning, RL. Here, neural networks are fed often similar amounts of unlabeled data, but allow the algorithm to interact in an environment where specific outputs are rewarded. When you click on Facebook ads, you are more likely to see those ads again. Deep learning, DL, is a related training technique where deep refers to the multiple layers of the network needed to transform data. Simpler tasks reside deeper in the network and then combine to inform output layers. In facial recognition, for example, the model needs first to recognize which groups of pixels constitute faces before it can extract features and then finally match features to known faces. These machine learning techniques mirror human learning with both its advantages and disadvantages. London-based DeepMind, now a subsidiary of Google, could have taught its DeepQ network to play video games like Pong by programming in the rules, an expert systems approach. This, like cheating, would have been faster. But by using these much slower trial-and-error techniques, DeepQ network can now generalize and, like humans, learn the next Atari game much faster. Since the model was learning directly from data, it could also create strategy in ways not limited by human assumptions, with implications for both creativity and accuracy. These DeepMind programs took longer to learn for themselves, but eventually exceeded human capabilities. Together, deep neural networks and machine learning techniques allow us to build foundational models. Since they are trained on very large and varied data sets, they are general-purpose systems whose broad capabilities are still being discovered. Few anticipated that these new models could decode brain scans, fMRI, back into the images that subjects were viewing. Part of what makes new AI technology so different and potentially dangerous is that we are still discovering what it can do. Large language models, LLMs, are foundational models that were initially focused on language, but also created new ways to analyze DNA, music, computer code, and brainwaves. The big 6 LLMs we have today are GPT from OpenAI, Palm from Google, Llama from Meta, Claude from Anthropic, Pi from Inflection, Grok from xAI. Think of these models as different types of intelligence, like comparing Marie Curie, Maya Angelou, and Cesar Chavez. They are different in neural networks, and they have been trained differently. Different, metaphorically, in both nature and nurture. Glossary 1. Artificial intelligence, AI, refers to the ability of computer systems to mimic human intelligence and also the development of such systems. Expert systems use rules and logic to anticipate a wide range of possible scenarios. Machine learning uses probability and statistics to recognize patterns and generalize. Neural networks are computing systems modeled like the neural connections in the human brain. Foundational models are deep neural networks trained with a large data set using machine learning techniques that mimic human trial and error. Large language models, LLMs, are foundational models focused on language. GPT stands for Generative Pre-trained Transformers. Foundational models and LLMs all use GPT architecture. It is not unique to OpenAI or ChatGPT. Diffusion models are a type of foundational model used to create images and video. Tools like DALL-E, Stable Diffusion, Midjourney are trained by adding noise to the training data, which the model learns to remove. The Turing test and AI thinking. Alan Turing first considered the question, "Can machines think?" in his paper, Computing Machinery and Intelligence. Turing argued that since thinking is hard to define, his original question is meaningless, and he replaced it with a version of the imitation game, where the interrogator asks two players questions and receives answers, all through text on computer screens. In Turing's twist, one subject is a human and the other is an AI. The interrogator attempts to determine which is the human. What we now call the Turing test is not about thinking, consciousness, intelligence, understanding, sentience, or anything to do with how a program might be processing. It is Turing's replacement of the question, "Can machines think?" with the question, "Can this chatbot make us believe we are interacting with a human?" In 2022, Google engineer Blake Limon was fired for claiming that Google's chatbot had become sentient. A clear pass of the Turing test. An AI does not have to think. Believing a chatbot is sentient is enough. LLMs use a combination of technologies to mimic human language and predict the next word, including deep neural networks that mimic human learning,
increasing computer speed and capacity,
vast amounts of existing human data, and a renewed emphasis on a machine learning strategy that relies on probability and statistics. In the same way that adding friction to a match creates fire in a new way, the returning focus on probability and machine learning in the 1990s unlocked the door to new generative AI. After encountering GPT-3 in 2020, philosopher David Chalmers wrote, "It suggests a potential mindless path to artificial general intelligence, or AGI." ChatGPT was a breakthrough, but it was also built on compromises. Hallucinations and bias. The G and the P in GPT. The process of pre-training, the P in generative pre-trained transformers or GPT models, and AI is lengthy and requires an enormous data set. GPT-3 was trained on 45 terabytes of textual data, more than 12 trillion words. That is also why large language models are large. Since the pre-training sources, including the monthly Common Crawl dataset taken from billions of web pages, contains the good, bad, and ugly of human thought, and since LLMs assimilate to predict, they are bound to reproduce the bias and hate in their source material. AI can also amplify the bias on the internet. When Stable Diffusion, an AI capable of creating photorealistic images, is asked to create images related to high-paying jobs, the images have lighter skin tones than when asked about lower-paying jobs, with 3 times as many men over women in the high-paying jobs. When asked for images of doctors, only 7% of the images generated are women, when 39% of U.S. doctors are women. Stable Diffusion exaggerates existing inequities, which is apparent in images in the Internet training set. Images generated by other AI image creators also yield biases. Adobe's Firefly AI image generator tries to correct this by making the number of women or black doctors proportional to the population of that group in the United States. Half the images of doctors it generates are women, and 14% of the doctors are black, even though only 6% of U.S. doctors are black. Firefly has been trained to increase the probability that a request for an image of a Supreme Court justice in 1960 will be a woman, even though Sandra Day O'Connor became the first woman appointed to the court in 1981. Bias can come from training data, but the well-intentioned Firefly examples highlight another set of potential problems. Human reviewers who rate and provide feedback for the model's output also have bias. If AIs can create images of the world as it could be, or as it is, who gets to choose? Bias can also be hidden in network architecture, decoding algorithms, model goals, and perhaps more worrisome, in the undiscovered potential of these models. The G in GPT is for generative, because these models generate new sentences, images, and ideas by sorting probabilities of a next word or pixel. They are prone to generate false data or fabricate fictional references. They will put ideas and words together in ways that humans might never have done before. They will put ideas and words together in ways that humans might never have done before. More on this in Chapter 4. This same design feature that allows LLMs to provide new and different answers to the same prompt also causes unpredictability and a lack of reliability. AI is also generative of misinformation. There are ways to reduce both of these problems, but they will be difficult to eliminate because both are direct consequences of the ways AIs learn to mimic human thinking. The bias is largely a result of the pre-training, and the potential for hallucination is built into the generative part of GPT. Transformers. The T in GPT. Understanding the T in GPT, transformers, but not the ones in the movies, is harder and also puts parameters and tokens in our path.
Sample complete. Ready to continue?